Hey guys, this is Mr. Wolf, and I'm going to go over page 27 of your physics packet. So if you guys could open up to that. Really quick before we start, I'm going to make a note. You'll see that section in the middle. It says Analyzing Word Problems, Course Targets 1, 3, 4, and 5. Just go ahead. That's something that actually got stuck there from last year. Cross that out. We are going to start again, though, with that average speed and velocity below that. So we're going to be working on target 5 today, and you can kind of see it's a little complicated, and it's important to understand how this target breaks down, but I'm going to go ahead and I simplify the target. So basically what target 5 is saying is I could use what I already know from the other targets from this unit to analyze word problems about constant motion. So we're going to go to average speed, and we talked about speed and velocity before, but we're going to talk about this idea of average speed. All right? And so average speed is the total distance divided by the total time it takes to cover that distance. And just as a reminder, speed is going to be a scalar quantity because it is magnitude only. So an example of this average speed is that, let's say we have Doug from Up, the dog. All right. So this is going to look more like a bear. So Doug the bear, he's got his little cone. And he sees a tennis ball over here. Now, Doug might go towards the tennis ball, but then stop and see a squirrel. He might go towards the tennis ball, stop and see a squirrel, and then go to the tennis ball. Now, we don't really care about his speed at any exact moment of time, such as right here or right here. What we care about is that total distance that he went, right, in that amount of time. So that's going to be our average speed. All right, so then there's also average velocity, and so velocity is like speed. It has a magnitude, but the difference, let me get to it, is that it's a vector. Velocity is a vector, and the easiest way to remember that is velocity starts with a v, so does vector. And so it's going to have a direction. It's going to go up, down in the positive direction or in the negative direction. So average velocity is a rate at which position is changing. So let's look at the definition of the word rate. It's really just an amount relative to something else, in this case time. So an example would be heart rate, which is beats per minute, or faucet flow rate, which is gallons per minute. Really what it's saying is if we're going 5 meters per second, for every 1 second, you will have traveled 5 meters. So average speed and velocity. When an object moves straight ahead and does not change direction, distance and displacement will have the same value. Right, so an example of this is, if you guys remember from the previous video, where we had that fly start here and he would fly like that, or across the room, and end here. Here our distance is the length of that line, and our displacement is just where he started and finished. And so those two are different. But let's say the fly starts here, and he flies in a straight line right here. In this case, our distance is the same as our displacement. They're equal. All right, and so here is the equation. And if you were in my first period, you saw me draw this out on the board. For third period, we will get to this on Tuesday. But this is basically what it is that velocity is equal to the displacement divided by time. And this really is what a rate is. It's something covered in an amount of time. And so what this line above the V is right here is that stands for the average velocity. So remember that idea of we just care about that total distance that something has been covered in an amount of time. Right, and so you could also write this equation just by rearranging variables to be the change in distance is equal to velocity, average velocity times time. Same thing. All right, so here's an example, and so you guys could follow along at the bottom of page 27 of how to go through a problem. So a car travels a length of road at 320 meters. For 320 meters. Sorry if it says at. Let me fix that. So that's the distance. Assuming the car travels this distance in 11 seconds, what speed is the car traveling? All right, so first we're going to look at our givens, all right? And we have our displacement, which is equal to 320 meters. We have our time, which was equal to 11 seconds. And we have our unknown in this case is we're looking for that speed, so that velocity for our equation. And so the equation we're going to use is the one up from before, where the average velocity is equal to the change in distance over time. So we're just going to really plug in our variables since we only have one variable left. So our average velocity is going to equal 320 meters divided by 11 seconds. All right. And we are going to get an answer of, if you use your calculator, 29.09 meters per second. So the idea is that for every second, this car traveled on average about 29 meters. All right, so there's an example. If you guys flip over to page 29, there's numbers 1 and number 2. I want you guys to try that out for homework. I'll be checking that on Tuesday. Don't worry about 3 and 4. We'll get to that in class. So have a great Labor Day weekend, guys, and I look forward to seeing you guys on Tuesday.